What's up, math scholars? I've got super exciting news to share with you this morning. First of all, it's Thursday and we're about to have a 4-day weekend. Who's excited about that? Yeah! Second of all, I got an email about 15 minutes ago, and guess what? It's my YouTube-versary. It's been 1 year since my first video lesson I uploaded. And here's how my channel did this month. I got 9 new subscribers this month, 276 views, and that's over 1,000 minutes of mathematics watch. Woo! You guys are scholars! I mean, that put a smile on my face.
525,000 total minutes.
Well, it's been 1 year since my first video upload. I started last
How can you
October.
just don't make us watch the ones from last year?
Oh, that's no fun, because then you'd be like, Mrs. Harper's the laziest person ever. She sits on her desk and hits play. I'm sure.
No,
I'm sure a parent would complain to Crocker like within the day. So I changed my lesson slightly. I do change some slides. Like that's a different warm up today. There's a few different slides on here from last year. I mean the content is obviously the same, but there's different things. And I want to keep it interesting. All right, so let's talk end behavior. End behavior is the behavior of the graph as x approaches infinity, or as you travel to the end of the graph. It is determined by degree and the sign of the leading coefficient. So here's some new shapes we get to learn about today. It's just kind of exciting. Cubics and quartics. All right, so we do have to have a little chat about infinity. Okay, so
That's not what it is.
we're going to go ahead and chat about infinity. All right. First of all, let's just talk about like a coordinate plane and where infinity would live on a coordinate plane. We're going to introduce the concept of negative infinity today, which is a concept I don't think you've ever talked about in a previous course. So if I would travel on my coordinate plane in this direction, and I would keep traveling forever and ever and ever, in positive infinity would live out in this direction, right? Positive infinity. If I would travel on my x-axis in the other direction to the left, forever and ever and ever, that's where negative infinity would live. So there can be a concept of positive forever and a concept of negative forever. Does that make sense? Mm-hmm. I feel like that's a new concept that people like have trouble grasping in their brains. Okay, let's do the same thing with the y-axis. Oops. If I go on my y-axis up and up and up and up and up forever into the sky, that's where positive infinity lives on the y-axis. And then if I travel on my y-axis down and down and down and down below the ground, that's where negative infinity will live. Everybody kind of is in agreement on that. Okay, because they're going to start asking us questions about graphs. First of all, let's look at the graphs we're going to be studying today. There's going to be a new shape, and it's called a snake. Everybody go like this? That is a snake, and that is what a graph of x to the third power would look like. It's called a cubic. So x to the third power, x to the fifth power, x to the seventh power. Anytime the degree is on, it's going to make a snake shape. Here's how snakes work. As x approaches infinity, their y values would go up to the sky. So as x approaches infinity, y would approach infinity. So maybe draw a snake on your paper. As x approaches negative infinity, so as x goes to the left, these graphs head down towards the ground. So as x approaches negative infinity, y approaches negative infinity. This is another word for y. That's a concept there. Over here, it's just a backward snake. The thing that would cause the snake to flip upside down would be a leading coefficient that is negative. It's just going to flip it and reverse kind of the end behavior. As x would approach infinity, so as you would travel to the right, the graph will go down to the ground. So the y values approach negative infinity. As x approaches negative infinity, so as we go to the left, the graph goes up to the sky. So as x approaches negative infinity, y approaches infinity. I probably wouldn't write down all these end behaviors. I would probably just write down like the picture of the sketch, what a positive snake looks like. It looks like this. And what a negative snake looks like. It looks like this. And then down on the bottom, this is when your degree is even, like x squared or x to the fourth or x to the sixth. It has an overall shape of a parabola. Sometimes it has a weird awkward wave in the middle. But it starts high and ends high if the leading coefficient is positive. And it starts low and ends low if the leading coefficient is negative. Let's talk end behavior. With parabolas, end behavior is easier. because as x goes to infinity or as x goes to negative infinity, both of these end arrows are heading up towards infinity.
Go down and up. Down.
So down and then up like this would be like a snake, so it would be an x to the third or an x to the
Then why
fifth.
is the fourth?
The fourth just has this weird little wave, and a sixth. I mean, I know what you're saying, normal parabolas just go like this. Those are x squareds. It's x to the fourth, x to the sixth that cause little waves.
What does it do?
It's just what the numbers do mathematically when they raise to those exponents. And then over here, this would be an upside down parabola. So that both the end behaviors are this is going to negative infinity and this is going to negative infinity. I'm going to have a question here. Alrighty, we have a little multiple choice question. When I first look at it, I kind of see, is it making a snake shape or like a parabola type of shape? It's making pretty much like a parabola type of shape. Now, parabola type of shape has to have an even degree, like either x squared, x to the fourth, x to the sixth. Is this parabola opening up towards the sky or down towards the ground?
Down.
Down towards the ground. So it has to have a negative out front of the equation. And that's called a negative leading coefficient. So let's see if that's enough information to maybe pick our answer. Degree is even, bam. Leading coefficient is negative, bam. It's D. Does that make sense how we kind of narrowed it down? Okay, let's try another one. I think there's one more like this, kind of. Describe the degree and the leading coefficient. Are we looking at a snake or a parabola type of shape? It's a snake. Now, snakes can have two overall shapes. Positive snakes look like this. And I realize the YouTubers, you can't see my arms right now. So a positive snake would look like this. A negative snake, make it with your arms, it would look like this. So what are we dealing with here? This would be a negative snake. So it would have a negative leading coefficient. And it would have an odd degree. That's what creates snakes. Odd degree, such as x to the third, x to the fifth, x to the seventh. Make sense? Okay. We're going to basically, from here on out, just make a bunch of these graphs in our calculator. We're going to make the table, plot some points, think about the end behavior, and then connect them. So it's all in the calculator, pretty much. Here's our first slide. Before I even started, I kind of look at what I'm going to be dealing with. So what's the degree? 3, so it'll be a snake. There's a negative out front, so it's going to be a negative snake. Can you show me that with your arms? A negative snake. So I'm backwards from you guys. So like this, right? Like this. Face the board. I can't do mirror images with my arms. All right, so let's pull up the calculator, graph it, and fill out our little table. So you go into your y equals, that's where you put your equation in. Negative x to the third less x squared. Oh no, I'm gonna go over and type it in at my computer because I'm kind of messing up my exponent. You gotta make your cursor big again. You gotta hit the right arrow to make your cursor big again. That is something I forgot to do. I'm going to peek at the picture just to see that negative snake. Let's peek at the picture. Oh, my shading is still turned on. You probably want to turn your shading off. This is like a disastrous day for me, huh?
That actually looks kind of cool.
It did look cool. It was a snake that was shaded above, but we don't want any shading turned on anymore, so we just want to
Not
go
yet.
back to a line.
Will we be learning about that soon?
Shading? No, we don't. I don't think we ever shade above snakes this year.
Is it next year?
Maybe.
What about shading below them?
I mean, you can shade wherever you want to shade, but this problem is just an equal sign, so it's just a line. All right, and I'm going to fill out the table just because they did ask us to do that. Trying to move my calculator over out of the way. There we go. So we're going to go into our table, second table. I'm going to fill out some values. Looks like I'm going to have to scroll up to find negative 3. Negative 3 is at 20. Is that 24?
Yeah.
I'm almost too close to see it accurately. 24, 3, negative 4.
Negative 3.
Yeah, thanks. Just keep going on the list for me.
Negative 1, negative 12.
0 first. It's like negative 1, negative
Yeah.
I missed one.
0, negative 3.
So it went from -4 to 0.
4. Negative 4 to negative 3 to 0.
Okay. And then?
Negative 1.
And then?
Negative 12.
And my... You know how my board's not lined up. I can't quite get my chart lined up, but do a little bit better job at lining up your values of your chart. Oh, let's pause the video and line the board. All right, we're back. We lined our board up. We got our values a little bit better. Having these values written down allow me to graph my graph a little more accurately than just kind of draw a snake wherever I feel like drawing it. 1, 0 is right here. 0, -3 is right here. 2, -1 is right here. 3, -12 will be off my picture. -1, -4 would be down here. And -2, 3 would be up here. Alright, so I'm going to try to connect with a smooth curve best I can, making it a negative snake. Is this about what you're seeing? Now, let's answer some questions about end behavior. I thought the questions were on the slide, but they're not, so I'll just ask them verbally. As x approaches infinity, what happens to the y values? So as I go towards infinity on my x-axis, are my y values growing or shrinking? I'm going down to the ground. Perfect. So if they're going down to the ground, they're going towards negative infinity. Okay, that's the first end behavior question. The second question is, as x approaches negative infinity, what happens to our y values? What do they approach? So as we travel left on our graph, what happens to our y values? They're shooting upwards, right? If they're shooting upwards, they're going towards infinity. Yeah. Sure, yeah. That is end behavior. So basically your end behavior, you're always answering either infinity or negative infinity on these problems. You want to try another? Probably just do like one more and be done. Does that sound good?
Yeah.
All right. It's Thursday and Logan has 4 tests to study for today. All right. We're going to go ahead and type this in, fill out our table, draw it, and answer our end behavior questions. Oh, that's going to cover up my equation. Okay. Clear out your old one. Your shading's already turned off, so that's not going to be a problem. X to the 4th. Make your cursor big again with your right arrow. Minus x to the 3rd. Make your cursor big again. Minus 4x squared. Plus 4. Hey, before we hit graph, let's just think about it. What's the degree of this polynomial? Degree 4, which means it's going to be either a parabola opening up or a parabola opening down. What do we think? Opening up, because there's a +1 as its leading coefficient. There might be weird, funky waves happening in the middle. Let's graph and see. There's a couple funky little mountains and valleys in the middle, but overall it starts up and ends up like a parabola way. Yeah. Okay. Alright, we're going to go ahead and fill out our table now. Just to give us some actual values to be able to graph. Second table takes us there. 76, 12, 2, and 4. And then 0, -4, and 22. And I'll graph the ones that'll fit on my picture. -1, 2, 0, 4, 1, 0, 2, -4. And it was kind of a parabola starting high and ending high, so I just kind of remember that as I'm connecting. Okay. So let's answer some end behavior questions. As x approaches infinity, what do the y values do? Approach where? They go up, so they go towards infinity as well. And then as x approaches negative infinity, so as we go to the left, what happens to the y values? They go up as well. So both of my answers are infinities for that one. All right, I'll leave that up in case you're still writing. Your homework tonight, you already have it. It's just the back side of the paper from last night. Just making a bunch of graphs, making a bunch of tables. Shouldn't be a huge problem, okay? Thanks for watching the video. Happy long weekend.